Good morning, Rachel and Becky. I thought that I would help you out by doing a little bit of vocab here before you got to this part of the packet. So on page 5, problem number 3, you're going to encounter this symbol. It looks like an upside down U, and it means intersection. Another word for this would be and. So it's simple as it is. So whenever we're talking about different sets, different collections of things, the intersection of those things is where is this and this. So as you can see behind me, I'm sitting over here near a bunch of books. So I thought it would be a great example. We start off by talking about different sets of books. One set of books could be paperback books. So if a book is paperback, it belongs in that section. If it's not paperback, it does not belong in that section. Another set of books would be fiction books. So if it's fiction, it belongs in that section. If it is not, it does not belong in that section. And whenever I have the intersection of fiction and paperback, it's where I find books that are both fiction and paperback. So if it's just one, doesn't count. If it's just the other one, doesn't count. But if it's both, then that's what we're looking at, the intersection between fiction and paperback. Now, on that page in your packet, you're going to find a problem where you're looking at the intersection of 3 different sets. You're going to be looking at the sets of positive integers, so that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. You're going to be looking at the numbers that are less than or equal to 20. So that would be 20, 19, 18, 17, 16, all the way through negative infinity. But also it's going to be including decimals and fractions, everything throughout there. And then the third set you're going to be looking at is all even numbers. So that's going to be 2, 4, 6, 8, 10. And as far as you can go. But whenever you're looking at the intersection of them, then that's going to narrow things down a little bit. Because if I'm only looking at positive integers, then that knocks out any fractions and decimals. So I don't have to worry about those anymore. And then whenever I look at set B, all numbers less than or equal to 20, then I don't have to consider 21, 22, 23, 24, all the way up to infinity. So now the intersection between A and B, that's going to be positive integers and numbers that are less than or equal to 20, just those two, is going to give me only 1 through 20 whole numbers. So now that I'm only dealing with 1 through 20 whole numbers, then I have the intersection where those meet with C, and C is even numbers. Then the only numbers that fit that criteria are going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. That's it. Because if it's not positive, it can't be on the list. If it's not less than or equal to 20, it can't be on the list. And if it's not an even number, it can't be on the list. So it has to be all 3 of those things. It's the intersection of all 3 sets. And then this particular problem asks you to find the sum. So I wouldn't want to do the whole problem for you, and take away all that math enjoyment for you, but once you figure this out, you've got your solution there. So we're going to work more on intersections the next time I see you. So I hope you guys do really well with this, and I'll see you next week. Take care. Bye.